It's a common paradox. We see systems filled with intelligent people operating under what appear to be logical rules, yet they produce catastrophic, seemingly irrational outcomes. So what's going on here? This explainer will examine the underlying structure that causes these kinds of failures.
Now, our typical assumption is that a major failure has to be the result of a specific error, a faulty part, a bad decision, or some moment of incompetence. But what we find in many complex systems is that failure isn't an anomaly at all. It can actually be a normal, even inevitable outcome of the system just operating exactly as it was designed.
So to really understand this paradox, we first need a clear definition of a system. And it's not just a collection of things. It's a set of interconnected elements. And those connections are what's crucial here, because they're what cause the system to produce its own unique pattern of behavior over time, a pattern that's often completely independent of the intentions of any single part.
Okay, so how does this behavior lead to failure? Well, to analyze that, we can break down a huge range of systems into just 3 core components.
So first, you have the actors, the individuals or entities operating inside the system. Second, there's a shared resource that all of those actors depend on. And third, you have a set of rules that govern how the actors are supposed to interact with that resource.
All right, now let's look at the logic of local choice. The mechanism that drives a system toward failure often doesn't start with a big mistake. Instead, it begins with a series of what seem to be perfectly logical choices made by individual actors.
This is what we call local rationality. It just means that from the very narrow perspective of an individual actor, a certain choice makes complete sense. Why? Because it offers a direct, immediate benefit to them.
And here's where the incentive structure often becomes, well, fundamentally skewed. Think about it like this. An actor takes an action and they get to keep 100% of the benefit. But the negative consequence of that same action, let's say a tiny bit of damage to the shared resource, gets distributed across everyone in the system. So for that one individual, the personal cost feels like almost nothing.
The ecologist Garrett Hardin famously described this dynamic. He pointed out how this structure essentially locks every actor into a system that compels them to act in their own best interest. And in doing so, they unknowingly contribute to the ruin of the very resource they all need to survive.
So let's talk about how these small actions accumulate. The key thing to remember is that the failure doesn't happen all at once. It's the result of a slow, almost invisible accumulation of thousands of these small, rational decisions piling up over time.
Taken by itself, any single one of these actions is pretty much insignificant. Its effect on the whole system is just too small to even notice, let alone measure. But when thousands of different actors all make that same rational choice, their combined actions start to create this steady, unseen pressure. And it's this pressure that slowly degrades the shared resource. The tricky part is, most of the time, no single actor is even aware of how much they're contributing to the overall decline.
This dynamic kicks off what's known as a reinforcing feedback loop. See, as some actors start to benefit from taking a certain action, it incentivizes others to do the exact same thing, maybe just to stay competitive. The output of the action, that individual gain, becomes an input that encourages more of the same action. And this just accelerates the pressure on the whole system.
Now, you might think this accumulated pressure would lead to a slow, predictable decline, but that's not usually what happens. Instead, it creates the perfect conditions for a sudden, cascading breakdown. And there are 2 key characteristics of many modern systems that explain why this is the case.
The first of these is complexity. This just means the system has so many interconnected parts that the ways they interact become wildly unpredictable. It's literally impossible to anticipate every single potential chain reaction. The second characteristic is something called tight coupling. This means the components are linked together so directly that there's no slack, no buffer in the system. A change in one part doesn't just affect another part later on, it impacts it immediately and directly. This allows even a small disruption to spread like wildfire.
So when you combine these 2 things, complexity and tight coupling, you get a powerful result. The sociologist Charles Perrow argued that in a system like this, major accidents aren't just possible, they're a normal, even inevitable property of the system itself. He actually called them normal accidents.
So what this means is that the final breakdown isn't the result of one person's mistake or one part failing. It's what's known as an emergent property. It's an outcome that arises from the complex interactions of the system's overall structure, not from any of its individual pieces.
Okay, so this entire process we've just walked through, it reveals a really fundamental principle about how we can decode the true nature of pretty much any system. A system, when you get right down to it, is defined by the behavior it consistently produces. Any stated goals or intentions, they don't really matter if the actual outcomes are different. The real purpose of a system is what it does.
And that observable pattern of behavior, that's the key to everything. It's what reveals the true, often unspoken, rules and incentives that are really embedded deep in the system structure.
So that catastrophic failure that seems so irrational from the outside, it isn't a flaw in an otherwise rational system. It's the perfectly logical output of the incentives and structures that are baked into its design. The outcome isn't an accident, it is the design.